Sir, shall I? Hello everyone, I am Dr. Sridhar, NEET faculty in Gurudev Academy. So welcome to the Gurudev Academy. Today I am in live to discuss the NEET chemistry question paper. Okay? Yes, please. Come to the first question. Wood spirit is known as. See, among the option, methanol is known as wood spirit. Okay, option B is the right answer for the question. What is the question number 2? Yes. Which of the following hormone containing the iodine? Yes, here there are 4 options. Option A, that is the testosterone, adrenaline, thyroxine and insulin. Yes, among these, thyroxine is an hormone which contains the iodine. Well, so option C is the right answer for the question. Okay, well, go to the question number 48. Well, which of the following order is incorrect? So we need to find the incorrect order here. See, the first option, AlCl3 is greater than, MgCl2 is greater than NaCl, the polarizing power. Yes, the answer A is the right answer, statement, because greater the charges, greater the polarizing power. Okay, option A is the right option, but we need to find out the incorrect statement. Okay, na? So A is not an incorrect statement. Well, go to the next. B, CO, CO2 and CO3 minus 2 bond length. Here the CO3 minus 2 is having greater bond length. Yes, of course, it is a correct statement. Okay, na? Well, go to the option C. BeCl2 is lesser, NaF3 is greater, and NF3 is still more greater regarding the dipole moment. Yes, of course, NH3 is having greater dipole moment than the NF3 as BaCl2. Of course, option C is also correct statement. So remaining only one, the D option is the remaining incorrect statement. Okay, well, how come the B is incorrect? They are asking the bond angle. Here BF3 is having a smaller bond angle as compared to the water. Other actually is wrong. BF3 is having greater the bond angle because the boron is bonded with the 3-fluorine atom and it do not have any lone pair of electron. There is no repulsion. Hence, it shows the bond angle as 120. Actually, it should be a greater bond angle than compared to the other 3. Hence, the incorrect statement is D. So, D is the right answer for the question number 48. Well, go to the next question. Question number 49. Yes, what they given? A weak acid is a dissociation constant of 10 to the power of minus 5 is being titrated with aqueous NaOH solution. The pH of the pH at the point of 1/3 of neutralization of the acid will be. So here we need to find out the pH of the 1/3 of the neutralization. Listen, how can we calculate this problem? This problem can be calculated very easily in only 3 steps. So they given the dissociation constant of the weak acid. They given here. So let's write the dissociation constant of the weak acid. That is pKa. That pKa value nothing but as what? 10 to the power of minus 5. But they asked to calculate the pH of the solution. Okay, na? When it makes the 1/3 of the neutralization. Yes. So it is a basic buffer solution. It is an example of. It is an basic buffer solution. It is an example for what? Basic buffer solution. By using this one, we can calculate a pH of the solution. That is a pH is equal to what? That is pKa plus log of what? Salt divided by acid. So by using this formula, I will calculate the pH. But here they given the pH at the point of 1/3 of neutralization. What do you mean by 1/3 of the neutralization? 1/3 of neutralization of acid is equal to 1/3 of neutralization means salt divided by acid is equal to, that is 1 divided by 3 into 3 by 2. So now I will cancel the 3 and 3, the remaining, that is salt divided by acid is equal to 1 by 2. So now I will substitute the value here. Now pH is equal to, okay, the dissociation constant of is 10 to the power of minus 5. So K is 10 to the power of minus 5. Then what about the pK? That is become 10 to the power of 5. So that is called as 5 plus log of 1 by 2. Then pH is equal to 5. When you make the reciprocal of this 1 by 2, then it become what? Minus log 2. So the answer is pH is equal to, that is 5 minus log 2. So which is the right answer here? Yes, the option B is the right answer for the question 49. Okay, so like this, in shortcut method we can solve the problems here. Okay, well, fine, go to the next question. Yeah, I need to wipe here for every time. Well, read the question here. So what question this is? Question number 50. For one of the element, various successive ionization enthalpies in kilojoule per mole are given in the below. In the table they given the ionization enthalpy, that is first ionization, second ionization, third ionization, fourth ionization and fifth ionization they given. So we need to find which is that element, element. So we need to check the large difference in the ionization enthalpy. So here 577.5, second ionization enthalpy is 1810. There is no, I am not finding there is much difference. Then go to the second and third difference, 1810 and 2715. Here also in second and third ionization enthalpy I can't find much difference. Next go to the third and fifth, 2750 and 11580. So here I can find there is a large difference in the ionization enthalpy between the third and fourth ionization enthalpy. So where there is a third and fourth ionization enthalpy, there is a large difference. Greater the large difference in the ionization enthalpy, then it is following the water complete outermost shell completely filled. That indicates. So by losing the 3 electrons, which is the element become is complete their outermost shell. Yes, among these aluminium will losing by electron. Okay, it will shows complete filling their outermost shell. Okay, so that is the reason why aluminium atomic number is 30. By releasing the 3 electrons, okay, that is 1s2, 2s2, 2p6, 3s2, 3p1. Now this is K shell, L shell and M shell. By releasing the 3 electrons, it will become what? Al plus 3. So after third one, if you want to release the one more electron from the 2p, it required more energy. Okay, now for the fourth ionization enthalpy, it required more energy because of the 2p orbital is completely filled. Okay, hence the element is aluminium, that is D option. Okay, well, fine. Go to the next problem, question number 51. Yes. Assertion: a very dilute acidic solution of cadmium plus 2 and Ni plus 2, nickel plus 2, give yellow precipitate of cadmium sulfide on passing H2S. Yes, of course. Then cadmium and nickel ion and nickel ion, when passes through the hydrogen sulfide, it forms the cadmium sulfide. Okay, na? Yes, the assertion is the correct. Assertion is the correct and true. Go to the reason. The solubility product of cadmium sulfide is more than that of nickel sulfide. No, actually solubility product of cadmium sulfide is less. Okay, na? So the reason is the false. As a result, I can say that only that assertion is true, reason is the false. Hence option C is the right answer for the question here. Okay, well, go to the next question then. Just I will wipe. Well, go to the question number 52. Which of the following increasing order is not correct as mentioned in the property with it? So we need to write the correct answer regarding the property based on the increasing order is not correct. Okay, now which one is not correct, that we need to predict here. Okay, yes. So from the option A, B, C and D, okay, now I will start with option 4, oxidation number of the iodine. So check the oxidation number of the Hi4. In Hi4 oxidation number is 7. In ICl oxidation number is +1. In I2 oxidation number of iodine is 0. In Hi oxidation number of the iodine is -1. But here HiO4 is having greater oxidation number as compared to the other, but in the option D they given as lesser, and the increasing order is not correct in the option D I can find. So option D is the right answer for the question here. Okay, well, fine. Just I will wipe and I will go to the question number, that is 53. Yes. Go to the question number 53. Which of the following pair of isomers is not correctly matched with its a type of isomerism? So this question is based on the coordination compounds. Okay, which pair of isomers is not correctly matched? That we need to find out here. Okay, well, fine. Go to the option here. Option A, CONH3 taken 6, CrCN6, and CrNH3 taken 6, and CONCN taken 6. This is an example for coordination isomer. Yes, of course, it is an example for the coordination isomers. Okay, this is the right one, but we need to find out which is not correctly matched. That we need to find out. Well, go to the question number, option number 2, CONH3 taken 5, NO2 square bracket Cl2, and CONH3 taken 5, ONO square bracket Cl2. It is a linkage isomer. Yes, of course, your nitrogen is bonded to the cobalt and your oxygen is bonded to the cobalt. So, yes, of course, it is a linkage isomer. It is also correct. Go to the next one. COPy taken 2, H2O taken 2, Cl2 square bracket Cl2, and COPy taken 2, then H2O, Cl2, square bracket H2O. Here one water molecule is inside, another water molecule is outside the sphere. Hence, it should be a hydrated isomer, but here they given water coordination isomer. Hence, it is not become a coordination isomer. It should be a hydrated isomer. Hence, option B is the right answer. It means it is not correctly matched. So, C option is the right answer for the question number 53. Okay, well, go to the next question. Well, see, ketones, that is RCOR dash, where R is equal to R dash, nothing but as they are considered as alkyl group. It can be prepared in one step by. Means, how can you prepare the ketones by in one step? Yes, of course, as we know that already is a theoretical concept. Secondary alcohols easily undergo, okay, gives the ketone. That's what I'm saying, that oxidation of the secondary alcohols easily gives the ketones. So we know that oxidation of primary alcohols gives aldehydes. Oxidation of secondary alcohols gives ketones. Okay, now as per the question, answer C is the right answer for the question here. Okay, yes. Next, go to the next question, question number 55. Well, which one of the following gives amines on heating with the amide? On heating with amide nothing but as, that is RC double bond O NH2. Okay, na? When amide treated with which type of components, it will give amines. Okay, na? So it undergo Hoffman's bromide degradation when amides are treated with the bromine in the presence of the aqueous KOH, so resulting in the formation of the amines. So it undergo Hoffman's bromide degradation. Hence, so bromine in aqueous KOH, A option is the right answer for the question. It undergo Hoffman bromide degradation. Hence, option A is the right answer for the question here. Okay, well. Yes, go to the next question then. Well, fine. Question number 56. The correct order of increasing basic strength of the following compounds. So, here they given the 5 molecules they given, okay, in which we need to write increasing basic strength of the following compound. Well, fine. So, we should know that basic strength. We should know that basic strength is directly proportional to the electron donating group, and it is inversely proportional to the what? Electron withdrawing group. So based on this concept, okay, just I will solve within 1 minute. This is an aniline. It do not containing nitrogen containing lone pair of electron. It do not containing electron withdrawing or electron donating. But in this paranitronline, so nitrogen, okay, the NO2 group, it is an electron withdrawing group. In fourth option, okay, so this methyl group, it is an electron donating group. In this fourth molecule, that aniline is bonded with at para position methoxy. That methoxy is an electron donating group. It is a more electron donating group because of the oxygen containing the lone pair of electron. And here at the meta position, okay, it is also having electron withdrawing group. As compared to the nitro, it is a para will be more electron withdrawing, okay, this meta will be less electron withdrawing, okay. So which one is more electron donating? So methyl group is a less electron donating and methox is a more electron donating. As for the concept, okay, the first one will that the fourth molecule is having more basic, okay, the second one will go to what? Third molecule is having a more basic, and the fourth place goes to what? The first, third place goes to what? The third place goes to what? First molecule, and fifth molecule will go for the fourth place, and the least basic is what? A second molecule, that is 5. Hence the option is which is the right option there? Yes, option A is the right answer. Okay, sorry. Yes, option A is the right answer for the question. Yes, see that fourth molecule is having greater basic in nature, and the second molecule is having a least basic in nature. Okay, yes, so answer A is the right answer for the question here. Well, go to the next question. Okay, yes. Yes, when this reactant react with B2H6 in the presence of the THF, that is tetrahydrofuran, in the presence of hydrogen peroxide with the OH minus, it gives A. The product A is. So what is the product here? Okay, when the given molecule, that is carbon bonded with 3-methyl molecule with CH, double bond CH2. When this molecule is treated with the diborane in the presence of a tetrahydrofuran along with in the presence of hydrogen peroxide with basic condition. Yes, here it follows the water, addition of water molecules takes place, okay, by following the anti-Markovnik's rule. By following the water, anti-Markovnik's rule. So it is undergo hydroboration. It undergo water, hydroboration, and also it forms anti-Markovnik's rule. It forms what? Anti-Markovnik's rule. In this anti-Markovnik's rule, OH is added to the, okay, the carbon which containing more number of hydrogen, means OH should be attached here and H should be attached here. So resulting in the formation of the ultimate product is this one. Okay, yes, answer C is the right answer. Okay, because it the reaction is undergo hydroboration, and also it follows the anti-Markovitch rule. So resulting in the formation of OH is attached to the carbon containing more hydrogen, and H is attached to the carbon containing less number of hydrogen between carbon-carbon double bond. Okay, yes, by following these reactions, just I can get the answer. C is the right answer for the question. Well, move to the next question, question number 58. See, we need to solve the problem for this one. Yes, what it says, phenol association in benzene to a certain extent to form a dimer. A solution containing 2 into 10 to the power of minus 2 kg of phenol in 10 kg of benzene, and it has a freezing point depression by 0.69 Kelvin. Next, the degree of association of phenol is, that is Kf for the benzene. The degree of association of the phenol is, see the degree of association of phenol nothing but as alpha is equal to how much? If they given as Kf, that is Kf is equal to what? 5.12 Kelvin kg per mole. So we need to calculate alpha here. If you want to calculate the alpha, we need to calculate I. If you want to know the I value, then I want to know the, that is a calculated molecular mass of the solute. So first we need to calculate the molecular mass of the solute, then followed by we need to know the Vanta factor. Then with the help of the Vanta factor, we need to calculate the alpha, that is degree of dissociation of phenol. It's a lengthy problem, so it need minimum 3 to 4 minutes. Okay, yes, let's begin. So they given the depression of a freezing point they given. So based on that one, just directly I will solve. That is delta TF is equal to Kf into Wb divided by Mb into what? 1000 divided by Wa. So the delta TF value already they given. What is the depression freezing point here? That is 0.69 Kelvin. 0.69 Kelvin is equal to Kf value already they given, that is 5.12 into the weight of the solute. Okay, now so the how much they given weight of the solute? The solute containing 2.0 into 10 to the power of minus 2 kg, 2 into 10 to the power of minus 2 kg divided by molecular mass, that I need to calculate as Mb. Okay, na, into what? 1000 divided by Wa. Wa means they given how much here? The weight of the solvent? Yes, they given 1 kg of the benzene, that is 1 kg they given. See, the overall on solving, I will get the value, that is Mb is equal to, on complete simplifying, I will get the value as 148.4 grams. That is molecular mass of the solute, that is 148 grams. Just already I mentioned, first we need to calculate Mb. Yes, of course, I calculated the molecular mass of the solute, Mb I calculated here. Next, with the support of molecular mass of the solute, I can calculate easily, that is Vanta factor, that is I is equal to, that I is equal to what? That is M2, that is a calculated value divided by molecular of the observed one, that is molecular mass of the observed one. Then I is equal to, so what is the calculated value? The molar mass of the phenol. Phenol is the water. Yes, that phenol is the water. Calculated one. The molar mass of the phenol. Molar mass, just I'll write here. Molar mass of phenol is equal to 94 gram. That is the calculated value. So 94 divided by the molecular mass observed. How much I got here? That's MB 148.4. 148.4. On simplifying, I am going to get the value 0.633. The I value, I got it here. Now, with the support of the I value, I will calculate the alpha. Okay. Well, fine. Just I need some space here. So, I will wipe here. Well, now do the calculation. See, they clearly mentioned the degree of association of phenol. So, 2 molecules of phenols are associated, gives and 1 molecule. That's what I am going to write the reaction here. 2 molecules of C6H5OH. It is an undergo association resulting in the formation of C6H5OH taken twice. See, 2 that phenol molecules are undergo association will give what? Here, this is only one molecule here. Yes. Then what about the reaction? It is 1 minus alpha and it is alpha by 2. So now, then what is the total species? Then total species is equal to 1 minus alpha plus alpha by 2 is equal to 1 minus alpha by 2. See, I am going to solve the problem. The total species is equal to 1 minus alpha plus alpha by 2. See, on simplifying this one, I am going to get it as 1 minus alpha by 2. I am going to get it as what? 1 minus alpha by 2. Then next, I is equal to what? That is, I is equal to 1 minus alpha by 2 divided by 1. See, on taking cross and on further simplification, I can get it, that is 1 by alpha 2 is equal to 1 minus I. Okay, now take this 1 on upper side, I into 1, 1. On further simplification, I am going to get it as alpha by 2 is equal to 1 minus I. Now, I know the I value, so substitute the I value and get the result. Okay. See, on substituting the I value, ultimately we are going to get that alpha is equal to 0.734. To get the percentage, alpha is equal to 73.4 percentage. Okay, so like this, so we need to simplify the problem. Okay, it's a little bit lengthy problem. Okay, so they ask the alpha here. If you want to calculate the alpha, we should know I. If you want to calculate the I, we should know the molecular mass of the solute. Okay, so first I calculate the molecular mass of the solute, then I substitute the here to get the I value. Then with the help of the support of I calculate the alpha. Okay, so in this way just I calculated so finally the degree of dissociation, the degree of association for the phenol is 73.4 percentage. Okay, well, fine. The next, yeah, go to the next question, question number 59. Well, just a minute. The question is merged here. The question is, okay, not merged. Yeah, please. Question number 59. Delta U is equal to. So delta U is equal to what? So we know that from the first law of thermodynamics, that is delta U is equal to Q plus W. In adiabatic condition, Q is equal to 0. Then substitute the value. Then delta U is equal to 0 plus W. Then ultimately I can get delta U is equal to W. Nothing but as, okay, delta U is equal to, okay, na, adiabatic work done. Delta U is equal to W, nothing but as adiabatic work done. Hence, for the question number 15, option A is the right answer. Okay, well, go to the next question then. Well, question number 60. Among the following series of transition metals ion, the one where all metal ions have 3d2 electronic configuration. So which metals will have, or can all metal have 3d2 electronic configuration? So we know the 3D series elements, that is scandium, titanium, vanadium, chromium and manganese. Here they given from titanium to manganese they given. I am going to take it as titanium, vanadium, chromium and manganese. Titanium atomic number is 22. It is having electronic configuration 3d2 and 4s2. By removing 2 electrons, it will become what? Ti plus 2. So Ti plus 2, it is having 2 electrons in the 3D series. Next, vanadium nothing but as 23. It is electronic configuration 3d2, that is 4s2. By removing the 3 electrons, so 2 from here and 1 from here, it will become as vanadium plus 3. It will become what? Vanadium plus 3. So vanadium plus 3, it containing 2 electrons in the 3d orbital. So remaining atomic number of the chromium is 24. Its electronic configuration is 3d4 4s2. By removing the 2 electrons from the 4s and 2 electrons from the 3d, okay na, it will become chromium plus 4, okay na, and remaining 2 electrons will be there in the 3d series. And the last one is manganese. Manganese atomic number is 25. its electronic configuration 3d5 4s2 by removing the 2 electrons from the 4s and the 3 electrons from the 3d, okay na, it will become what? Mn plus 5. So here also 3d2 electrons will be remaining here. So then which ions having 3d2 electrons? Ti plus 2, V plus 3, Cr plus 4 and Mn plus 2. Hence answer D is the right answer for the question here. Okay, well, fine. Now go to the next problem here. Question number 61. Well, fine. Just I will wipe. Well, fine. If equilibrium constant of the following equilibria, that is SO2 plus O2 gives equilibrium with SO3, and 2SO3 equilibrium with 2SO2 and O2 are given by K1 and K2. So this is nothing but as K1 and this reaction nothing but as what? K2. Which of the following relation is correct? It's one of the very easiest concept here. I'm going to write here SO2 plus of O2 is equilibrium with SO3. This one I'm considered as a K1, and another reaction is, that is 2SO3 is equilibrium with 2SO2 plus O2. This is a what? K2. Okay. So write the K1 here. What is K1 here? That K1 is equal to product divided by reactant, that is SO3 whole to the power what? Only one reactant, divided by reactant. How many are there? SO2 whole to the power. Then K2 is equal to, that is SO2 whole to the power of 2 and O2 whole to the power of 1 divided by SO3 whole to the power of 2 here. Is it clear, guys? Okay. Now we need to correlate the K1 and K2. We need to correlate the K1 and K2. This is equation number 1 and this is equation number 2. From equation 1 and 2, just correlate here. Now what happens here? That is K2 is equal to 1 divided by K1 square. K2 is equal to 1 divided by K1 square. See, because when you make this one reciprocal, okay na, then it becomes square. So ultimately I can get it as what? K2 is equal to 1 divided by K1 to the square. K1 to the whole square. Then which is the right answer here? This is just simplification concept here. Yes. So option A is the right answer. That is K2 is equal to 1 divided by K1. Why I taken? Because K1 containing only one SO3, the K2 containing 2 SO3. Just here I taken K2 is equal to inverse of K1 square. Okay, just I made the cross multiplication, just I simplified, that's it. So here ultimately I got the answer. A is the right answer for the question. Well, fine. Go to the next question then. Well, which of the following is an optically active compound? So to become optically active, as once the carbon which should bonded with the 4 different species. Okay na? Yes. Among this one, okay na, that one butanol is not optically active, one propanol is not an active. Yes, one chlorobutane is optically active. So butane nothing but as it should have 2 chlorobutane. So there is a carbon, 2 chloro, CH3, H and C2H5. 2 chlorobutane is a chiral carbon, optically active. So to become optically active, the carbon should be what a chiral center. Okay, and this carbon will bonded with the 4 different species. Here chlorine, here methyl, here hydrogen, and here is what a ethyl. Like this, the carbon is bonded with the 4 different species. Hence, it is a chiral center. Yes, answer C is the right answer for the question. Well, go to the next question then. Sorry. Yes. Which one of the following represent the smallest quantity? Which of the following is the smallest quantity? Yes, option A given 1850 Ng. N nothing but as nano, that is 10 to the power of, 9. It is a 10 to the power of what? 9. Yes. So 1850 N. N nothing but as what? Nano, nothing but as what? 10 to the power of minus 9. So here 1.85 in 10 to the power of minus 4 grams. So directly they given. Here 1.85 into 10 to the power of mu gram, that is mu is equal to 10 to the power of minus 6. And here 1.85 10 to the power of minus 6 kg. Kg is also directly given. So here which is the smallest? Nano is having a smallest value, that is 10 to the power of minus 9. Hence option A is the smallest quantity. Option A is the smallest quantity. Yes. Well, fine. Go to the next problem then. Well, which of the following system is most stable for the chelate? Which of the following system is the most stable for the chelate? So based upon the chelate, I can say that greater the cyclic structures, greater the cyclic system, then greater will be the stable. Among this one, it is a 2 fuse structure, 3, 4 and 5 fuse structures. Greater the carbon atoms in the cyclic structure, the fuse structure, then greater will be the stability. Hence, option D is the right answer for the question here. Okay. Yes, greater will be the number of chelating rings, greater will be the stability. That's it. Well, fine. Go to the next problem then. Question number 65. Which of the following exhibit aromaticity by the Huckel's rule? Okay, now which one following the Huckel's rule? We know that Huckel's rule, that is 4n plus 2 pi electrons, where n is the number of rings. Okay, now if so n is equal to 0. If n is equal to 0, then 4 into 0 plus 2. How much it become? It is having 2 pi electrons. Then if n is equal to 1, if n is equal to 1, that is 4 into 1 plus 2 pi electrons. That is how much? 6 pi electrons. Like this 10 pi electrons. Like this 14 pi electrons. If the molecule containing 2, 6, 10, 14 pi electrons, then it is following the Huckel's rule. Yes, option A, it's containing 1, 2, 3, 4, 5, 6. 6 to the 12 pi electrons it have. It is not following octet. 1, 2, 3. It is also having 6 pi electrons. And here 1 plus lone pair of electrons. Yes, it's having 4 pi electrons. And here also it is having 4 pi electrons. Yes, among these, okay, na, option B, it is having 6 pi electrons. Okay, na, by following the Huckel's rule, and so option B is the right answer. Well, go to the next one. Well, the order of reactivity of methyl halide in the formation of the Grignard reagent. During the formation of the RMGX, which is the alkyl halide is in the order. As we know that iodine is having a bigger size. Hence it easily involving in the reaction. Because that is alkyl iodide is least stable. Because alkyl iodide, that is Ri, is the least stable. Because it is the least stable. Because of the least stable, it is involving in the formation of the Grignard reagent. Okay. And next one is that bromine. After that chlorine. That chlorine can be easily react. So among the option for the 66 question, okay, na, option A is the right answer, because CH3I is involved in the form. Well, go to the next then. Well, the ionization enthalpy of the second period element vary with the atomic number as. Yes, they given here the graph, that is ionization enthalpy of atomic number A, and B is here, and C is having less, and D is more, and E is also little more than D, and as compared to F is decreases, and C is again G is increases here. See which element represents the point B and E. The point B and E. See, the point B and E is having a more ionization enthalpy compared to the next element. Look at here. B is having more energy compared to the next, and E is also having more energy compared to the next element. Then which are those? So as usually the elements which following complete and awfully filled. Okay, now the completely filled and awfully filled will shows more ionization enthalpy, even though compared to the next group elements. Okay. Yes, among these beryllium carbon is awfully filled, not awfully filled. Boron, nitrogen. Boron will not become. Nitrogen is of course awfully filled. Beryllium, oxygen. That beryllium is a 4s orbital is sorry, 2s orbital is completely filled, but not oxygen. Beryllium and nitrogen. Yes, of course. Beryllium atomic number is 4. If write the electronic configuration 1s2 and 2s2. Okay, so beryllium is having greater energy because s orbital is completely filled. So B is the beryllium. Beryllium is having greater initial enthalpy than the next one. Next, nitrogen. Nitrogen is having atomic number 7. If you write the electronic configuration, that is 1s2, 2s2, 2p3. See, that p orbital is awfully filled. Because of the awfully filled, nitrogen is having a greater ionization enthalpy than compared to the next one. Hence, the right answer is the D. Well, go to the next problem then. Yes. The structure of the compound that gives a tribromo derivative on treatment with the bromine water. So, which molecule on treated with the bromine in water, okay, na, which one will give tribromo? Which one will give tribromo? Well, fine. Here, look at here, OH. This OH group is electron donating group. This electron donating, it activate the ortho and para position. Ortho and para position. When OH bonded here, these both ortho and para positions are completely free. Okay, hence it easily undergo tribromo. So here OH is bonded to the alkyl next to that benzene, it does not undergo easily. Here OH bonded phenol containing para position methyl, it also does not undergo. That phenol containing ortho positionally, it is having what, a methyl group, it also does not undergo. So option A, that is that benzene, okay, it is having OH along with at the meta position CS3. When it is undergo bromination, okay, it easily undergo tribromo, okay, components it will use, that is Br, ERBr and ERBr, because at the meta position it is having a methyl groups. Hence option A, it is an undergo when it undergo bromination, it gives tribromo derivatives. Yes. Go to the next question. Well, fine. Two solutions X and Y electrolytes are taken in two beakers. Yes, I will take a beaker 1 and I will take beaker 2. It is X and it is Y. Separately I taken and diluted by adding 500 ml. Of course, I will add here 500 ml of water. Of course, here I will add 500 ml of water. I will add. Next. The lambda m of X is increased by 1.5 times. So lambda m, okay, now molar conductivity is increased by only 1.5 times. While that Y is increased by 20 times. Means lambda m is increased by what? 20 times. Then what would be the electrolyte X and Y? Then what would be the X? What is X and what is Y? See, I can explain very clearly within a minute. See, this X is an electrolyte. On diluting by adding 500 ml of water, its molar conductivity is increased by very small because X should be completely dissociated. On dilution, the number of ions will be remaining almost all same. So there is no much changes in the lambda m. That indicates X should be a strong electrolyte. That should be what? A strong electrolyte. Next, Y on dilution 500 ml, that lambda m is increased 20 times. That indicates Y should be a weak electrolyte. An addition of water, okay, that ionization goes on increases. As ionization goes on increases, the number of ions increases. As number of ions increases, then lambda m is also increases. That I am saying that Y should be what? Weak electrolyte. Yes, find the answer now. So X is strong electrolyte, nothing but as X NaCl, Y KCl. No, both are strong. X is NaCl, Y is acetic acid. Yes, it is a strong electrolyte and it is a weak electrolyte. Hence answer B is the right answer for the question. Well, fine. Go to the next one. Well, which of the following electronic configuration is not possible? Which of the following electronic configuration is not possible? Yes. Say if n is equal to 3, then L is equal to 0 and M also become what? 0. Okay. Yes, it is possible because L is equal to 0, then M also becomes 0. Okay, it is possible. Next here, if N is equal to 3, L is equal to 1, M is equal to 1. Yes, of course, if L is equal to 1, then M is equal to -1, 0, +1. It is also possible. Next, go to the C. If N is equal to 0, then L is equal to 0. If L is equal to 0, M also should become what? 0. Okay, na? It cannot be a -1. So, which is not possible? Option C is not possible. Option C is not possible. Okay. Yes, of course, D is also is possible. Hence, option C is the not possible for the electronic configuration. Okay. Well, fine. Answer C is the right answer for the question. Well, go to the next question then. Well, C2H5OH means ethanol and C6H5OH and phenol can be distinguished by. How can you distinguish by ethanol? That is C2H5OH and phenol. How can I distinguish this one? Yes, it can be easily distinguished by various methods, but among the given option, bromine in water, sodium metal, iodine NaOH, and both B and C. Yes, I can easily get it identified by using the iodoform test, that is so iodine in NaOH, because when ethanol react with the iodine in the presence of the NaOH, it forms iodoform reaction takes place, but when phenol treated with iodine in the presence of NaOH, no reaction takes place. No reactions takes place. That's what okay na, that ethanol and phenol can be easily distinguished by using the iodine in NaOH. Hence option C is the right answer for the question here. Well, go to the next question. Question number 72. Which transition in the hydrogen atomic spectrum while have the same wavelength as the transition n is equal to 4 and n is equal to 2 of the helium plus spectrum? So we need to calculate what is the n1 and n2 for the hydrogen atomic, because they given the n1 and n2 value for the helium. That's what I am writing here for helium +1 spectrum. Okay na, n1 is equal to how much? 2, then n2 is equal to 4. Then calculate the 1 by lambda value. 1 by lambda is equal to z square into r into 1 divided by n1 square minus 1 divided by n2 square. Okay. Well, fine. So we need to calculate the n1 and n2 for the hydrogen. So again, just I will get simplification for this one. Put the value, that is 1 by lambda is equal to z square. Z means atomic number of this helium, how much here? That is 2 square into r. I will keep the r as it is. 1 divided by n1 square means what? 2 square minus n2 means what? 4 square. On simplifying, 1 by lambda is equal to, that is 2 2s are 4. 4 into r divided by 1 divided by 4 minus 1 divided by 4 4s are 16. So do the simplification. This one on further simplification I am getting it as 1 by lambda is equal to, that is 4r divided by 3r divided by 4. On this one further on simplification I will get the 3r divided by 4. So now I got the 1 by lambda value for the helium. Next, for hydrogen atomic spectrum, that is for H atom. For H atom, that is 1 by lambda is equal to z square into r into 1 divided by n1 square minus 1 divided by what? N square into square. N2 square. So we need to find out the n1 and n2 for the hydrogen atom. Then put the value. We know that 1 by r is equal to how much? 3r divided by 4. Then put the value 3r divided by 4. Okay na? It is on further simplifying is equal to z square means 1 square into r divided by what? 1 divided by n1 square minus 1 divided by n2 square. So this r and this r will get cancelled here. Okay. So on further simplification, that is 1 divided by n1 square minus 1 divided by what? N2 square is equal to how much I am going to get? That is a 3 by 4. I am going to get it is what? 3 by 4. So 1 divided by n1 square minus 1 divided by n2 square nothing but as is equal to 3 by 4. So then what is the n value? Then if you want n1 divided by n1 square minus 1 divided by n2 square nothing but as 3 by 4, then what should be the n1? So n1 and n2 is equal to, n1 is equal to 1 and n2 is equal to 2. So which is the right answer there? Yes, n is equal to 2, n is equal to 1. Answer D is the right answer. Okay, na? With the support of the helium He plus 1 spectrum, I calculated the n1 and n2 for the hydrogen. Yes, from the following question. So right answer is the D answer. Well, go to the next question then. The solution in a beaker turns blue if, which one? When copper electrode is placed in zinc ion further does not undergo reduction, so it is not possible. Copper electrode is placed in silver ion. Yes, of course. Just I will take a beaker. In this beaker, I will take the Ag plus 1 ion. Okay, na? Then I will put a copper electrode. In which copper ion is an undergo oxidation to become Cu plus 2 by releasing the 2 electrons. This is an undergo oxidation. And this is Ag plus 1 by 2 Ag plus 1 by gaining 2 electron to become what? Ag. Here copper, it is a brown color. When it become copper ion, then it is called blue color. Hence, option B, that is copper electrode is placed in AgNO3 solution, it turns the blue color. Option B is the right answer for the question here. Well, go to the next one. Sorry. Well, a salt on treatment with the dilute HCl gives pungent smelling gas and yellow precipitate. The salt gives green flame test and yellow precipitate with potassium chromate. The salt is. So they given 4 options here. We need to find out the salt. When the particular one salt is treated with HCl, it will give bad smelling and yellow precipitate. Next, it gives the green flame. So green flame, which element will use a green flame here? That is apple green. Yes, that barium, it will use the apple green. Yes, where is the barium? That is the right answer. Yes, among these one, option B, it's containing a barium. That is BaS2O3. When treated with HCl, it will give, of course, SO2. This SO2 is a pungent smelling gas will be there. Okay, na? And also it gives yellow precipitate. Next, that whatever the barium is there, when this barium ion, when substitute the flame, it will give apple green color. It will give a green flame test, nothing but as apple green color it will use on flame test. That indicates it containing the barium. Hence, the answer B is the right answer for the question here. That's it. It's a very simple. Well, go to the next problem then. Well, the rate constant of a first order reaction is, that is 5 into 10 to the power of minus 3 per second. So per second means it follows the first order reaction. How long will 5 grams of this reactant to take reduce 3 grams? So the concentration of the reactant, that is R0 is equal to 5 grams. Then after the reaction R will become what? How much? 3 gram. Then K is equal to 5 into 10 to the power of 5 into what? 10 to the power of, 3 gram. K is equal to 5 into 10 to the power of minus 3 per second. And what they asked, how long it will take means the T is equal to how much? Then calculate the T. T is equal to 2.303 divided by K into log of, that is R0 divided by R. So substitute the value. 2.303 divided by K means 5 into 10 to the power of minus 3 into log of R0 nothing but as 5 divided by R nothing but as 3. So now do the calculation. On calculating, okay na, so we are going to get the time is equal to how much here? 34.07 seconds. 34.07 seconds. So this is the time I am going to get here. So answer A is the right answer for the question here. Okay, yes, this is one of the easiest problem here from the chemical kinetics. Well, Go to the next one then. What they given here? An organic compound A having a molecular formula that is a C2H3N on reduction give another compound B. Okay, I will write the reaction. C2H3N nothing but as what? CH3 that is CH2 CN. I can take it as what? CH3 CH, not problem. I will wipe this one. CH3 C triple bond N. Yeah, that is there 2 carbon and 3 hydrogen nitrogen. Yes, CH3 C triple bond N. When this formula on reduction, this formula is on reduction give another compound B. When this molecule is on reduction, it will give what? This molecule is on reduction. So reduction nothing but as addition of hydrogen. Yes, of course, add the 2 hydrogen here and 2 hydrogen here. So resulting in the formation of CH3, CH2 single bond is what? NH2. Yes, of course, this is the B component. Okay, na? The A molecule is this one. When this A molecule, A molecular formula that is C2H3N, this is one, on reduction gives another compound B. Here, this is the B. Which upon treated with the nitrous acid, nitrous acid means what? HNO3. Any H? It is on treated nitrous acid, that is HNO2. That is a nitrous acid. Gives ethyl alcohol. Yes, when this primary amines are treated with the sodium nitrite, it gives an alcohol, that is CH3, CH2OH. Yes, of course, it gives alcohol. Next, on warming with the chloroform and alcoholic KOH, B forms. Yes, when this B is treated with the chloroform and alcoholic KOH. So when amines react with the chloroform and alcoholic KOH, it undergo carbylamine reaction. B forms an offensive smelling of compound C. The same thing, carbylamine reactions takes place, resulting in the formation of water. Okay, na isocyanate it forms. It forms what? Isocyanate. The compound C is, yes, of course, the compound C. This is the compound C. This is the what? Compound C. Okay, na? And it is an isocyanate. Yes, which is the right answer there? The right answer is what? B. CH2CH2NC. Okay, it's very simple. A in reduction gives B. B further undergo nitrous acid gives alcohol. This B further treated with chloroform with alcoholic KOH, it gives carbylamine and it gives the product C as a isocyanate. Yes, B is the isocyanate. It is the right answer for the question. Okay, well, fine. Go to the next question then. Well, match the plot given in the list 1 with their slopes given in the list 2. So based on the slope value, we match the list 1 and list 2. Select the correct answers using the codes given in the list here. Okay, yes. Here the C means concentration versus time for the zero order reaction. So concentration versus time for the zero order reaction is, okay, now which is the right answer for this one? Okay, yes, that P concentration time nothing but as for zero order means unit not zero. Yes, it should shows the minus K. Next, log C versus time. Log C versus time for the first order reaction. Log C versus time for the first order reaction nothing but as, that is minus K divided by 2.303. Well, go to the next. Minus dC divided by dt versus concentration. Change the concentration with respect to time versus concentration for zero order reaction. It should be a 0. It should be what? 0. At last, a ln of minus dC by dt versus ln C. It is for the first order. We have no options here. It shows the what? Unity. So here, this sequence, it exhibits the option C. This sequence exhibits the option C here. Well, fine. Go to the next problem then. Well, the deficiency of the following vitamins causes the conversion. Okay, now what is the causes of conversion? The causes of conversion means, okay, the improper supply of the electric charge to the brain. That is called as conversion. So which vitamin which causes the conversion? That vitamin B6 causes the conversion here. Okay, right answer is the B. Next, go to the next problem then. Question number 80. Which of the following represents the correct decreasing order of relative reactivity towards the electrophilic substitution reaction? So we need to write a decreasing order of their relative reactivity towards the electrophilic substitution reaction. Among the four options, I am saying that the D option will shows the decreasing order. Why, sir? Why it will shows? Because just I will show, that is paramethyl toluene. So this is the benzene and paramethyl toluene. This is the paramethyl toluene. Next one is what? C6H5CH3. The next one is what? Toluene. Only toluene I can write. The next one is paramethyl nitrobenzene. Yes, paramethyl nitrobenzene. Yes, this is what? CH3, and I can take is what? Nitrobenzene. The last one is what? Nitrobenzene. So last one is both side it is having nitro group. Yes, of course. See, they ask here the correct decreasing order of relative reactivity towards the electrophilic substitution. So which one is undergo electrophilic substitution reaction here? Electron withdrawing group will shows more, okay na, electrophilic substitution reaction, because look at here, it's a very simple. Here both are electron donating group. So electron donating group decreases the electrophilic substitution. Here two electron donating group. Here for this one electron donating group. Here there is a one electron donating group and one electron withdrawing group. But for this molecule, both electron withdrawing group will be there. So greater the electron withdrawing, then more will be the electrophilic substitution. Hence, this one will have more electron withdrawing group, so it undergo easily electrophilic substitution. Okay na? So the decreasing order relative nothing but as, of course, it is more and goes on, it is a decreases. Hence, option D is the right answer for the question here. Okay? Well, fine. Go to the next question then. Question number 80. Well, fine. Next one. Yeah, 81. I will wipe this. Go to the question number 81. Sorry. Yeah. An acidic solution as pH is equal to 6. It is diluted 100 times. Then pH of the resultant solution would be. So, an acidic solution pH is already 6. If it is diluted 100 times, then what is the pH of the solution? Okay, it's a very simple concept. Okay, without solving the problem, we can solve it by using some simple tricks. Just I am going to use those simple tricks. As we know that pH of the solution that is given, that pH is equal to 10, pH is equal to the given what? 6. Then what is the concentration of the H plus ion or H3O plus ion? The concentration of the H3O plus ion is equal to 10 to the power of minus 6. Okay. Next, when it is diluted 100 times, that is 10 to the power of minus 6 divided by 100. This 100 I can take 10 to the power of minus 6. So this 100 I can write it as 10 to the power of 2. I am taking this upside, 10 to the power of minus 6 into 10 to the power of minus 2. Answer taking common, 10 to the power of it become what? Minus 8. So the total on dilution. Okay na? See, on dilution, the concentration is become what? 10 to the power of minus 8. See, from this one I can say that there will be a that is hydronium ion due to the autoionization of water. Say this water molecule, it is an undergo autoionization, so resulting in the formation of the H plus ion. So if H plus ion or H3O plus ion it forms, then its acidic nature should be less than 7 or this acidic nature will shows a more acidic nature, or else the pH value it will shows in acidic nature. The pH value will show acidic nature nothing but as it should be less than 7. It should be what? Less than 7. Among the option which is having less than 7, near to the 7, yes, 5.95 and 6.95. Yes, of course. Yes, sorry for interrupt. Yes. So option B is having 6.95. This value which shows less than 7. That's what answer B is the right answer. Okay. Well, go to the next question then. Well, fine. Go to the next. The pair of species showing perfect tetrahedral geometry. Okay, now which one shows a perfect tetrahedral geometry? See here, PCl4 and NH3, that phosphorus, it is having bonded with the 4 chlorine atoms along with their positive charge. Of course, it will show perfect tetrahedral geometry because do not contain lone pair. Even nitrogen NH4, that is a nitrogen is bonded with the 4 hydrogen with the positive charge. Yes, of course, it also do not contain lone pair of electron. That's the reason why both will shows a perfect tetrahedral geometry. So option A is the right answer. But it is not possible in case of the BF3 and NH3 because of the presence of the lone pair of electron. Here also because of the presence of the lone pair of electron, it also can't show perfect crystalline. Here also because of the presence of lone pair of electron sulfur, SF4 also cannot show tetrahedral in geometry. Okay? Yes, the perfect tetrahedral geometry is given by the option A. Well, go to the next problem then. Sorry. Well, statement 1, chlorination of methane gives mixture of product. Yes, of course, chlorination of methane gives chloromethane, dichloromethane, trichloromethane and carbon tetrachloride. Yes, that statement 1 is the true. Next, statement 2, chlorination proceeds through the formation of carbon anion. No, chlorination of methane, it is that mechanism is not by formation of carbon anion. The mechanism it will follows free radical mechanism. Hence, reason is that statement 2 is wrong. Statement 1 is correct. Statement 2 is incorrect. Hence, option C is the right answer for the question here. Okay. Well, fine. Go to the next problem then. Well, question number 84. The number of radial nodes and angular nodes for the d orbital can be represented. For the d orbital, okay, now L is equal to what? That is N is equal to, for S orbital 0, P orbital 1 and D orbital is equal to 2. For the D orbital, okay, na? So I can take it as N is equal to what? 2. For the D orbital, I can take it as N is equal to 2. Next, so we need to calculate the number of radial nodes. Okay, na? For the radial nodes, to calculate the radial nodes, I am going to use the formula that is N minus L minus 1. Okay, so put the value for this one. So you can going to get the which value there. That is N and N. I will keep it as it is, minus 2 minus 1. That is N minus 3. So radial node is become what? N minus 3. Well, next I am coming for the angular node. What is the angular node? The angular node nothing but as what? Angular node nothing but as what? L. What is the L value here? The L value I can take it as what? 2 here. Then what is the total node? That is total node is equal to N minus 1. Okay, na? Then N minus 1. Then I can get is what is the radial node? Already I given N minus 3. Yes, of course. Here, where is the N minus 3? Here there are 2 N minus 3. And what is the angular node? L is equal to 2. Of course, L is equal to 2 here. And what is the total node? N minus 1. Where is the N minus 1? Here N minus L minus something 1 is there. But here N minus 1 is there. Yes, of course. Answer C is the right answer. Because N minus 3 is the radial node. Already is given here. Then plus 2 is angular node. Of course, already given here. And N minus 1 is the total node. Yes, of course, already given here. So option 4 is the right answer. Well, move to the next then. Well, question number 20, sorry. 84 just I completed. Go to the question number 85. Cerium, that is Z58, is an important member of the lanthanides. Of course, it is important member of the lanthanide. The cerium is an element. Which of the following statement about cerium is incorrect? So we need to find out the incorrect statement. Yes. The common oxidation state of the cerium is +3 and +4. Of course, cerium it will exhibit both +3 and +4 oxidation state. Option B. The Ce+3 oxidation state of cerium is most stable than that of +4 oxidation state. Of course, it is the right statement. Next, option C. The +4 oxidation state of the cerium is not known in the aqueous solution. Actually, it is an incorrect statement. Our incorrect statement is C. In aqueous solution, the cerium it exhibits both a +3 as well as +4. So, the incorrect statement is C. Go to the next problem then. Yeah, the correct order of spin only magnetic momentum among the following. Okay, they given many of the examples they given here. Okay, yes, of course, just I will take one by one examples here. I am going to take the zinc. Zinc atomic number is 28. If you remove the 2 electrons, okay, that becomes Zn plus 2. Zn plus 2 contain 28 electron. It is having 3d10 and 4s2. Sorry, but on removing the 2 electron, it will become 4s0. So d orbital is do not having lone pair of electrons, that is n is equal to what? 0. If n is equal to 0, then mu is also become what? 0 here. Well, fine. Now I am going to take the nickel, that is Ni. Okay, na? Nickel atomic number is how much here? 28. Okay, now if I take the Ni plus 2, then it become a 26 here. If I write electronic configuration, that is a 3d8, 4s0. So 3d8 means it is having how many number of unpaired of electrons? It is having 2 unpaired of electrons. Okay, na? It is having 2 unpaired of electrons. Then mu is equal to how much? 2.83. Like this, I am going to take it as a cobalt. Like this, I am going to take it as a cobalt. Cobalt, it is having atomic number how much? Sorry, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. So it is having a 27. Okay, na? Sorry, it is 3d8 means 1 second. Just I will do calculation here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Yes, of course, it is having 2 unpaired of electron. It is right. Next, cobalt, its atomic number 27. Okay, na? In CO, sorry. Oh, right, sorry. Ni plus 2, 26. Yeah. In CO plus 2, it is containing how much? 25 electrons. Okay, na? Yes, in 25 electrons, nothing but as we need to reduce here 28, here 27. Yeah. Now, yeah, in this cobalt plus 2, it is having how many electrons here? That is 3d7 and 4s2, and here it's how many unpaired of electrons? Here n is equal to 3, that is mu is equal to what? How much here? That is 3.87. At last, manganese, that manganese atomic number is how much? 25. Okay, na? It is having electronic configuration 3d5, 4s2, and by releasing 2 electrons, it become a 3d5, 4s0. So here it's containing n is equal to 5, then mu is equal to 5.92. So here the correct sequence of magnetic momentum is, which is having a lowest? Zinc is having a least and manganese is having highest. Yes, of course, you can see answer C. Manganese is having more magnetic momentum, cobalt is little more less, nickel little more less, and zinc is having a 0. Answer C is the right answer for the question here. Well, go to the next problem then. 87. 1.5 moles of each of XY2 and XY3 if weights, that is 96 gram and 120 gram respectively. The atomic masses of X and Y respectively. So here we need to calculate the atomic mass of the X and Y respectively. So we know that atomic weight of X and Y, okay, na, are taken as A and B. So now that is X Y2, X Y3, it is taken in the ratio of, that is 1.5 into a plus 2b is equal to 96, because x is taken as a, y is taken as b. Here there is a 1x and 2y, that is 2b is equal to molecular mass, they give 96 here. Like this, I am going to take it for another one, that is for the 120. Okay, now how many are there? x1 and y3 are there, that's what I am going to write it for this one. And 1.5 into a plus 3b is equal to what? 120, because there is a 1x, nothing but as 1a, and y3, nothing but as 3b. It is on further simplifying, what I am going to get, a plus 2b is equal to 64. It is on further simplification, that is a plus 3b is equal to how much here? 80. Then what is the a? On solving, which is on solving, a I am going to get it as 32, b I am going to get it as 16. Okay, na? So answer C is the right answer for the question. Well, fine. Go to the next question then. Question number 88. Which of the following group constitute basic radicals of the fourth group? So which elements are belongings to the fourth group here? Yes, among these one, lead, mercury, cadmium, they are not belongs to fourth group, they belong second group. Zinc, manganese and nickel ions, yes, of course these are elements which belongings to the what? Fourth group. Option B is the right answer for the question. Next. Question number 89. Question number 89. Yes. Which one of the following sequence represents the correct increasing order of their bond angle they given in the molecule? Okay, na? So we need to write the correct answer for based on the bond angle, increasing order of their bond angle. So greater the electronegativity, so lesser the bond angle here. Okay, na? Yes, of course, H2O and ClO, just I am going to comparison of all these. Among these, the correct increasing order of their bond angle is, yes, of course, the C is the right answer, because look at here, that OF, electronegativity will be more, that's the reason why repulsion is what? More, bond angle is decreases. Here, that is Cl is bonded with what? Double bond O, along with there is a lone pair of electron, along with there is a lone pair of electron. Here electronegativity is less, so bond angle is more. So that's the answer. C is the right answer for the question here. Next, come to the last question of this question paper, that live streaming is, yes, the color and magnetic nature of the manganate ion, that is what? MnO4 minus 2. MnO4 minus 2, its name is manganate ion. That manganate is green in color. That manganate ion is what? Green in color. Permanganate is purple in color. That permanganate nothing but as what? MnO4 minus 1 is a permanganate. Okay, it is a permanganate. But MnO4 minus 2 is only manganate ion. It is a manganate ion. So manganate ion is a green color, and also it will shows a paramagnetic in nature, and also it will shows what? Paramagnetic in nature. Hence the answer A is the answer A is the right answer for the question here. Okay, so these are all the important questions that what I discussed here for the NEET toppers. Okay, please watch these videos and get the knowledge. Okay, for more videos, please do subscribe and put the bell icon. Okay, na? Yes, tomorrow I am going to discuss our colleague discuss one more paper. Totally just we are going to discuss 10 question papers here. Okay, so every day we will discuss each paper from the chemistry department, of course, as a PCMB department. Okay, please watch and get more knowledge from this one. Okay, thank you so much. Thank you for watching.